Let's talk about why hijacks matter. Let's suppose that you would like to visit a particular website. To do so, you first need to issue a DNS query. Now, the authoritative DNS server for a particular domain might be located in a distant network. As we've discussed in previous lessons, the DNS uses a hierarchy to direct your query to the location of the authoritative name server. But ultimately, that authoritative name server has an IP address. And you use the Internet's routing protocol, the Border Gateway Protocol, to reach that IP address. What if an attacker were running a rogue DNS server and wanted to hijack your DNS query or to return a false IP address? Well, the attacker might use BGP to advertise a route for the IP prefix that contains that authoritative DNS server. And suddenly, your DNS queries, which were previously going to the legitimate server, are instead redirected to the rogue DNS server. So we might think of this as an attack whereby an attacker can use the BGP infrastructure to hijack a DNS query and masquerade as a legitimate service. It can get even worse than this. Let's now look at how a BGP route hijack can result in a man-in-the-middle attack, whereby your traffic ultimately reaches the correct destination, but the attacker successfully inserts themselves on the path. The problem with this particular route hijack attack is that all traffic destined for IPX is going to head for the attacker, even the traffic from the legitimate network. What we'd like to instead have happen is that traffic for IPX first goes to the hijacked location and then goes to the legitimate location. So the attacker effectively becomes a man in the middle. The problem is that we need to somehow disrupt the routes to the rest of the internet while leaving the routes between the attacker and the legitimate location intact so that traffic along this path can still head towards the legitimate AS.